So we talked about algebra. We talked about analysis. We talked about set theory. I didn't want to get to this part, but it actually gets a little bit difficult from here. Oh, by the way, analysis. Many topics that are covered in analysis also are. So we cover ideas of measure theory. Measure theory, we derive probability. That I will recommend Sheldon Ross. This is the classic book. I believe most probability classes, they use this book. So, a first course in probability by Sheldon Ross is the book you should read to learn probability. And we also, let's see. Also, analysis, you can also cover PDEs, partial differential equations, which is okay. Also, integration, differentiation, you get the idea. So, what is next? The next part is geometry, which is personally my most difficult subject. When I was a freshman, I learned manifolds as a freshman, and it was a difficult class for me personally. So, there's many definitions of manifolds. In geometry is the study of shapes, sizes, things like that. Coffee cups. We want to derive homeomorphisms, which is a function that is a homeomorphism of rank. Let's call it continuous. A continuous mapping from one structure to another, and the inverse is also continuous. And also the function has to be 1-to-1. And you know the truth. So the intuition between this, and I don't believe the intuition, is what the professor says is that there's no tearing. So a homeomorphism has to be continuous and it has to be proper. The inverse has to be continuous. So yes. We like to devise homeomorphism between different shapes, different objects. We like to study surfaces, k-dimensional parametrized surfaces. K-dimensional parametrized surface, it's a function from, it's a function. Some people, they like giving definitions of images, but I prefer the functional definition, because you need a domain for that also. Okay, it's function from, okay, parameterized surface. In RK, it's an open set. You need an open set U in RK or in open in the upper half space. Relatively open, of course. So it could intersect that K. You also need the function itself to be 1-to-1. Full rank. The determinant has to have full rank everywhere on the domain. The image of the function has to be open in the surface, in the space you're working in. So if we're talking about a k-dimensional parameterized manifold, that has to be open in M. Let's see, 1-to-1. Oh, it has to be proper also. So the inverse has to be continuous. If we say the k-dimensional CR parameterized manifold, it has to be class CR. So that's also important. Okay, I don't want to. My friend who's watching this, I don't want to confuse him. So let's just say that analysis, study of shapes, and it's quite complex, many complex proofs. For example, Harry-Ball theorem, fixed point theorem. Well, there's actually an analysis proof of the fixed point theorem, but there's also a geometry proof. Actually, it's more geometrical in my opinion. So that's geometry. And topology is an extension of geometry. Actually, next quarter I'll be taking differential topology. So I'll talk to you about that next quarter. So that's geometry. It's a manifold is particularly useful in geometry. For example, we live in a four-dimensional manifold, I believe. You can prove a ball, an upper half plane sphere is a manifold. We build manifolds from the images, union of images of k-dimensional parameterized surfaces. So that's interesting enough. And we actually can prove quite a few things about manifolds. For example, if the manifold has non-empty boundary, a non-empty boundary, then the boundary itself is an open manifold in Rk minus 1. So in geometry, we also study talked about surfaces. Okay, parameterized motion. So we can actually look at motion of a particle in Rn as a function of t. So that is parameterized curve is the correct term. There's quite a bit about parameterized curves. So that is, I think I'm just going to leave it there with geometry, because that is not my strong point. There's also number theory, but I still have to take that. So, but number theory overlaps a little bit with algebra. There's some results in algebra which are particularly useful in number theory. Okay, well, there's this girl that's right next to the door who wants to eat food, and I made her a promise too. So Mr. I shouldn't say your name. So my young friend, if you have any questions about the subject, you can just email me. And if anyone has a question, Math Ninja always has free time. I am always studying, always in my room. Just shoot me an email. So that was the major fields. There's more major fields, mind you. We talked about set theory, logic, analysis, algebra, and geometry. Did we talk about? Let's see, is there anything else? Yeah, there's more fields. There's descriptive set theory, there's algebraic topology. But I just want to leave it at that, because this has already gone on to be almost 50 minutes, I believe. Okay, thank you very much. This has been a great colloquial discussion. Well, Math Ninja, out.